Now let's review what we have done in today's lecture. The first thing that we analyzed was how to add parallel and series lumped elements to a circuit. So suppose that you were building a filter with inductors and capacitors that could be soldered into place. That's what lumped elements mean. Then this sort of analysis would be exactly what you would use. We also used that analysis to start helping us understand how we would add series or parallel distributed elements, the single stubs that are distributed, or basically printed transmission lines. So in that case, we could either do a series stub like this or a parallel stub like that. A series stub would look something like this. Connected onto the load, we would be designing a distance D and a stub with a length L. The stub could be either open-circuited or short-circuited at the end. A parallel stub would be similar, open-circuited or short-circuited on the end. It would be in parallel. Again, we would design a distance D and a stub length L. The steps to do this, if you recall, are to normalize ZL and plot it on the Smith chart. Rotate a distance D until you get to the matching circle. Read off the imaginary value, plot the negative of the imaginary value because that's what you want the input of the stub to be. Place that on the Smith chart and rotate a distance L until you get to the load of your stub. For the parallel stub, you do all of those things the same except that you immediately convert ZL to YL. The last thing we talked about was how to match a complex load with a quarter wave transformer. Basically there, you just take your load, whatever it happens to be, and you rotate it towards the generator, a distance D, until it gets to the real axis. That's any place here on this axis. That's going to allow you to put a quarter wave transformer in line with your complex load as long as you put a transmission line of length D in between your load and your quarter wave transformer. Now this gives you an awful lot of choices on how to match your circuit. There's one other choice I'd like to mention, and that's that when you're designing your series or parallel stubs, it's reasonable to replace the stub with a lumped element and solder it into place, thus often being able to reduce the size of the stub that's needed.